In this class, we're going to take a look at how you factorize polynomials using a technique called synthetic division. So remember that polynomials are in this kind of form here, but the power can be anything. So these are cubic polynomials. This would be a quadratic polynomial, but then you also get quartics and quintics where the powers are 4 and 5 and higher powers than that as well. If you've got something like a quadratic, so if you had x squared plus 8x plus, let me think of an example, say 12, then you can just factorize that directly. So you may have done these already in the past. You just put down your two brackets. It's not an easy technique, but you can learn it fairly quickly, and that one would just factorize like that. So it's a fairly quick sort of manual process. Once you move up to a power of 3 and above though, you can't really just perform that process quite so readily. So that's why we need another technique. And one of the techniques is synthetic division. You can also do algebraic long division, and there's various ways to do it, but synthetic division is quite a nice manageable technique. So that's what we're going to look at with these two examples. When you move up to powers of 4, sometimes you've got to do the synthetic division twice. So that's why we're going to stick with the power of 3 as our example. So the way that this works is there's two categories. Sometimes in one category, you're going to be told one of the factors. Remember that what we're trying to achieve here is just to write the polynomial in factorized form, which just means in its bracketed form. In this question type here, you're given the factor. The more complex version is when you're not given one of the factors, and we don't deal with that in this class today, but we do look at that in the course in detail. But the technique is the same. The only difference would be that sometimes you have to make this factor before you can get going with the technique. So what we're going to do here is use the synthetic division technique, which relies upon making a table. And the table just allows us to kind of keep track of our calculation. So what you do, you take the coefficients of these numbers. Remember that's a 1 in there. So 1, 3, minus 13 and 15. And you put those in the table. So 1, 3, minus 13, and then minus 15. And we put a number outside the table, and the number outside the table is the x value that would make this bracket that you already know 0. Or another way to think about it, whatever that number is there is the opposite of that number. So minus 1 in this case, the opposite side I should say of that number. That's not true though if that was say like a 2. If that was 2x plus 1, you would need to think of the x value that makes that 0. So that's the best way to think of it. Whatever value would make that 0 for x, that's the number that goes outside the synthetic division table. So the way the process works, whatever number lands up here in the first column, you just pull that down to the bottom. That's just how it goes. Then when a number lands here, you multiply it to this outside number. So 1 times minus 1 gives you minus 1, and you put the result in the next column. When a number lands in the columns, you always add them together. So 3 plus minus 1, well, that's just 3 minus 1. So that's 2. Minus 1 times 2 gives us minus 2. And then again, we just add those together. Minus 13 minus 2 is minus 15. Minus 15 times minus 1 is positive 15. And we add those together and we get a 0, which we usually put in this little box on the end. So that little box is called the remainder number. And it's just a little bit like if you divide numbers. So if you divided 15 by 3, you would get 15 divided by 3 is 5, remainder 0, because it divides in perfectly. This is kind of saying that this cubic here divided by x plus 1 would give you a remainder of 0, okay? But we also get, if you divide 15 by 3, you get the remainder of 0, but you also get the answer, which is 5. The answer this time is this bit here, and we call this bit the quotient. Okay, so that's a good term to know. So what the quotient is the other part of the factor. So in the same way that 3 times 5 gives you 15, we're saying that x plus 1 times this gives you the original cubic. So the way that this works, we pull down our x plus 1, that was just from there, and these numbers here are the coefficients of a trinomial. So it's 1x squared plus 2x minus 15. Remember, we're trying to put this into 3 brackets, so we're hoping that this will factorize into 2 brackets. So just keeping the x plus 1 where it was, putting down our 2 brackets here, factorizing x and an x. For this one, we'll need a 5 and a 3, a plus 5 and a minus 3. So this would factorize as x plus 1 Oh, I forgot my x there. So x plus 1 for the first bracket, x plus 5 for the second bracket, and then x minus 3. So that guy there can be written in factorised form like that, and we got there by using synthetic division. Okay, so that's basically the technique. It never really changes. Look out for the 0. You have to get the 0 to validate that that was indeed a factor. And it's given you both the 0 validation, but more importantly perhaps, it's given you the quotient, which then allows you to fully factorise. So let's go ahead and look at the second example. We'll just go straight into this one. So putting down our table. For this one, we're told that x plus 2 is a factor. So we'll just write that maybe up at the top. So we know that our first bracket is x plus 2. That means that minus 2 needs to go outside our table. In fact, sorry, no, it should be x minus 2. Okay, so x minus 2, meaning then that positive 2 needs to go outside our table. So the numbers for the coefficients, 1 minus 2 minus 1, 2. So 1, negative 2, negative 1, positive 2. So we're going to be looking for that 0 remainder again to validate that that is one of our factors. So just pulling down the first number, a 1, 1 times 2, I'm just going to take the plus out of there. So 1 times 2 gives you 2, adding these together and you get 0. 0 times 2 is 0, adding those together you get minus 1. Minus 1 times 2 is minus 2, adding those guys together in that final column, and we get the 0 that we were looking for. So that's perfect. So that tells us that that is a factor. So that tells us that f of x, I could have written this over here by the way, f of x, we could have said that was f of x there. So we now know that f of x is equal to that first bracket, the one that we were told about in the question, times the quotient. And the quotient this time is x squared, 0x, so there's no x term, minus 1. Now we know that this is a cubic, so cubics should factorise into 3 brackets. They don't always, by the way. Sometimes you just get this bit and then a quotient bit, this is a trinomial. But questions are generally going to be designed so that they are 3 brackets. Okay, so usually they will be. So having a look at that second bracket, that's actually a difference of squares. So you can actually factorise that into 2 brackets as x minus 1 and x plus 1. So that's it fully factorised. So that's how synthetic division works. It is a little weird at first. It will look odd. You'll get used to it very quickly. And in fact, it's quite a nice technique because if you don't get a 0 here, it tells you you've made a mistake. If you do get a 0, it tells you you've done it correctly. So it's kind of a self-check halfway through the question. So it's almost impossible to get that wrong, really. The more difficult version is when you don't get this original factor. If you don't know that, you've got to think a little more about how to make that first factor. It's not terribly difficult, but it takes a bit more effort than we've done there. But once you do have the factor, the process in the table is identical. So it's not a big stretch to get from this question type to that more complex question type. And we deal with that in a class in the course. So that's an introduction to synthetic division, and that's how we use synthetic division to factorise polynomial expressions.